Hi there, and once again, welcome back to How to Win at Chemistry. Last episode, we found the empirical formula of a hydrocarbon by using data from a combustion reaction. This time, we'll do a trickier example with a slightly more complicated compound. Last time, we used our masses of carbon dioxide and water from a combustion reaction to find our moles of carbon and hydrogen. We then used the moles of carbon and hydrogen to reach the empirical formula of the hydrocarbon. Today's compound will differ from the last one in that it contains oxygen. The problem here is that not all of the oxygen in our products came from the compound that we burned. In fact, most of the oxygen in the products came from the O2. So if we use our moles of carbon dioxide and water to reach moles of oxygen, we're going to end up with far, far too much oxygen in our answer. A better approach is this. When we find our moles of carbon and hydrogen, we find their mass as well. We then take the original mass of the unknown compound, minus the mass of carbon, and minus the mass of hydrogen. Whatever is left over must be the mass of oxygen, since it's the only element that we haven't calculated yet. We can follow that up by converting oxygen to moles, which means we would know the moles of all three elements. This allows us to calculate the empirical formula as before. With that in mind, let's have a look at today's problem. 7.2 grams of an unknown compound with C, H, and O is burned in a sealed chamber. Upon complete combustion, 17.6 grams of CO2 and 7.2 grams of water are released. Part A is to find the mass of carbon, hydrogen, and oxygen in the unknown compound. In Part A, our first step is to convert the mass of CO2 into moles of CO2, and use that to find moles of carbon and grams of carbon. For step 2, we'll repeat the process for water in order to find moles of hydrogen and grams of hydrogen. In our third step, we'll use the original mass minus the masses we just found to find the mass of oxygen. Once we have the masses, we'll move on to Part B. And our first step is to convert the grams to moles as before. After that, we'll reduce the moles to lowest terms and make sure they're all whole numbers. It's a long process, but let's take it one piece at a time. In Part A, Step 1, we're going to find the moles of carbon in our unknown, and we'll convert it to grams as well. We begin with 17.6 grams of CO2, and to get it to moles, we'll have to remember that moles equals mass over molar mass. From our previous problem, we know that CO2 has a molar mass of 44 grams. When we divide our 17.6 grams by 44, we get 0.4 moles of CO2. Also, since each CO2 has only 1 mole of carbon, that means the unknown we started with has 0.4 moles of carbon. Finally, to get the mass of carbon, we simply multiply our 0.4 moles by carbon's molar mass, which is 12. This gives us a carbon mass of 0.4 times 12, or 4.8 grams. Let's put this value aside for later. We'll be seeing it again in steps 3 and 4. For now, let's move on to hydrogen. Now for step 2, let's find the moles of hydrogen in our unknown and convert it to grams too. We begin with 7.2 grams of H2O, and once again we must remember that moles equals mass over molar mass. From the previous problem, we know that water has a molar mass of 18 grams. When we divide our 7.2 grams of H2O by 18, we get 0.4 moles of H2O. Now don't forget that each water has 2 hydrogen atoms, so we'll need to multiply that 0.4 by 2 to get the right moles of hydrogen. Hopefully you'll get 0.8 moles of hydrogen. Now just multiply by hydrogen's molar mass to get grams of hydrogen. Since hydrogen has a molar mass of 1, we have both 0.8 moles and 0.8 grams of hydrogen in our unknown compound. Now that we have grams of both carbon and hydrogen, we can find oxygen. To find oxygen grams, we take the unknown's mass minus the mass of carbon, minus the mass of hydrogen. Since we know the unknown's mass, the carbon mass, and the hydrogen mass, we can just plug in the values. From step 1, the carbon's mass was 4.8 grams, and from step 2, the hydrogen's mass was 0.8 grams. We also know that the unknown had a mass of 7.2 grams, so we can just do the algebra to find that the oxygen mass is 1.6 grams. Now that we have all three masses, after this, the problem is simply another empirical formula problem. Now it's time to move on to Part B, and let's begin by converting the grams we just found back to moles. We divide our carbon mass by its molar mass, and repeat the process for hydrogen and oxygen. For carbon, 4.8 over 12 gives us 0.4 moles, and hydrogen gives us 0.8 moles. We actually already found these numbers back in Part A, but it doesn't hurt to check. We also use our 1.6 grams of oxygen from Step 3, which we divide by 16, oxygen's molar mass. This gives us 0.1 moles of oxygen. We now divide all of our moles by the lowest number. We end up with 4 for carbon, 8 for hydrogen, and 1 for oxygen. Also, it looks like today is our lucky day, since we have no decimal numbers, so there's no need to make any adjustments. Our empirical formula is simply C4H8O, and there you have it. So now you see that some empirical formula problems can get a little involved, but with a little creative algebra and a little ingenuity, it's not as bad as it looks. Once again, thank you for watching, and remember to keep winning at chemistry.